So first things first, what we're going to do is it's asking for the expected value of the scenario. And we always do expected value the same way. Whenever you're asked to find an expected value, the very first thing you do is you make your probability distribution table every single time. So for the probability distribution table, you have to ask yourself, what are all of my outcomes and what's the probability of each of those outcomes? And the problem tells you to use the rounded midpoints for the ages. So the midpoint between 15 and 20, essentially 25, would be 20 years. So one of our outcomes is then continuing finding our averages, so it's just by adding the two numbers, dividing by 2, and then rounding. This would be 40, and then this would be 60. So therefore, 20 years, 40 years, 60 years. So now the question is what is the probability of each of these outcomes? Well, we know there are 29,000 people who are between the employed in the thousands. So it's actually 29,000, but whatever. That are the age of 20. So I'm going to write that number, 29,000 out of, and then so the next one's similar, 13,000 out of, and 3,800 out of. And now the question is out of what? Well, just a little bit of adding. If this is everybody, 29,000 plus 13,000 plus 3,800. And that comes out to be 45,800. So we're going to go ahead and say all of these are out of 45,800, 45,800, 45,800. I hope that makes sense. I'll make that a little bigger. So now we're ready to answer the expected value, because expected value is always calculated the same way. Once you have your probability distribution table, you have every possible outcome listed, the probability of each of those things. Now it's just the value times its probability. Whoops, excuse me. Added with the next one times its probability plus the next one times its probability, and so on and so forth. You just do this until you're out of options. So now I do this simple problem, just the math, and I get my answer. Now the one issue here though is when we read the directions, it does say to round all probabilities and intermediate calculations to 2 decimal places. So I think to get the answer that WebAssign is looking for, you actually can't use this fraction. You actually have to do and so therefore you get all these decimals. This value leads us to 0.63. This value leads us to 0.28. And then this value leads us to the 0.8. And once you do all that simplification, you end up getting, I'm getting 28.6. So if it's 2 decimal places, that'd be 0.60. So there's our expected value. So now what comes next? The next thing we have to worry about is standard deviation. So what is the standard deviation formula? Well, standard deviation is equal to the square root of the probability of our event times the value of that event minus the mean squared, and then plus, and repeat the process until you have no more events. So in this case we have 3 different events, all the different ages. So we're going to do this 3 times. And the next thing we have to remember is when we say mean, what we're really saying is just the concept of average. And in this case, if we assume if everything is distributed normally and whatnot. But so here, we're saying average. So in this case, we don't have average, but we do have the expected value. So we can use those interchangeably. So into your standard deviation formula, instead of just averages, you're going to use the expected values, substitute in, and that should get you going. Let me know if you need any more help.